Hi, this is Mrs. Slater, and today we're going to talk about graphs of linear equations. So before we start with the actual equations, we've got to figure out what is linear and what is not. So in most cases, you've seen a linear equation, and we're going to be using this quite a bit, is y equals mx plus b. So it's in that form. You knew exactly if it was a line or not. But what if it's not in that form? For example, 5y plus 8x equals 9. This is an example of a line because the exponents are in the first degree. So it's exponent of 1 for all of the variables. Let's look at another one. What about x equals 4 plus 7 over y? This is not a line because of the fraction. Well, even more importantly, because of the variable in denominator. Okay, the next one, 7y equals 11. Another way to look at it is that you can, anything that you can change into y equals mx plus b is going to be a line. This one would be yes, because you can put it in y equals mx plus b form, and then again because the exponent is 1 on the variable. Alright, let's try a couple more. X times y equals 0 is not a line because the two variables are multiplied together. And the last one I want to go over is 5x squared y equals 13. This one is also not a line because the exponent of the x is a 2, and that is not going to be a line. Okay, so let's go ahead and start graphing lines. One of the easiest points to find are the x-intercepts and the y-intercepts. By definition, the x-intercept is where the graph crosses the x-axis and same for the y-intercept. It's also where the graph crosses, but in this one it is the x-axis. Okay, so the way to find each one of these is to plug, for this one, to find the x-intercept, you would plug 0 in for y value, and then to find the y-intercept, you do the opposite. You're going to plug 0 in for x. Okay, so let's use that for the next couple examples. First is 4x plus 5y equals 20. So for this example, I'm going to use what's called the cover-up method. And since we know to find the x-intercept, we have to plug a 0 in for x. To find the x-intercept, let's go ahead and write this down. The x-intercept, we're going to plug a 0 in for y. So I'm going to take 0 and plug it in for the y right here. Well, anything times 0 is just 0. So that's why I call this the cover-up method, because that is no longer there. And what is the value of x? So 4 times 5 would give you 20. So the first point, or the x-intercept, would be 5, 0. Okay, so now let's do the cover-up method with the y-intercept. So with the y-intercept, you have to plug a 0 in for x. So that means we would cover up this because that would be a total of 0. and then 5 times 4 would give you 20. So we have our two intercepts. So when you graph them, 1, 2, 3, 4, 5 over, and then 1, 2, 3, 4, and connect your line with those 2 points, all you need is the y-intercept, and I think we're good to go. Okay, so let's go on to the next one using the x and y-intercepts and the cover-up method. The next one is 2x minus 6y equals a negative 2. Okay, so by using the x, or finding the x-intercept, we are going to plug a 0 in for y. So we would cover this side up. And 2x, what would that be? It would be a negative 1. That would fill in the x value. For your y-intercept, we plug a 0 in for x. And when we do that, we're going to cover up this side. Whoops. And if I solve for y, I end up with 1/3. Alright, so plotting the 2 points, negative 1, 0 lives right there, and 0, 1/3 is about right there. And all you need is your 2 points to connect them. And there you go. 2 points using the x-y-intercept and the y-intercept. Now, I'm going to give you another one, and I would like you to push pause and solve this. 3x plus 7y equals 21. Alright, now that you're back, the x-intercept, we're going to plug 0 in for y. So we're going to cover up the 7y. What's left over is 3x. 3x equals 21. What's the value of x? 7. So that's going to be our ordered pair. Okay, and then the next one you should have done is the y-intercept, which we plug a 0 in for x, and just cover up this one because it would be 0, and 7y equals 21, so that would be 3, a value of 3. Plot them, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, big points here, and then we can connect them with a line. Alright, so let's go on to the next item. The second method we're going to talk about today is graphing using the XY chart. So if you're given a y equals negative 2x, the XY chart is just a way to organize all of your ordered pairs. So we can plug in negative 2, negative 1, 0, 1, and 2. You really can pick any numbers you want. Those are the most common. And then when you plug the 2, negative 2 in for x, you end up with a positive 4. If you take the negative 1 and plug it in for x, you're going to get a positive 2. And if you take the 0 and plug it in, you're going to get 0, and so on. Okay, so once you have your ordered pairs, you go to your graph, plot your points. It's going to be to the left 2, 1, 2, 3, 4, and continue that same pattern with negative 1 and 2, and just plot all of your ordered pairs. 0, 0, 1, and then negative 2, and then 2, comma, negative 4. And then connect your line, and arrows at the end, and you're done. And that's how you graph using the XY chart. The third type is graph using y equals mx plus b, which is called the slope intercept form. And it gives, the name is given to this form because each letter represents something, and most importantly, the m is going to be the slope, and the b is going to be the y-intercept. Okay, and then the x and the y are points on the graph. Okay, so let's go ahead and practice one of these problems. Y equals 3x plus 4. So if you know the y-intercept, that is going to be a point at 0, 4, 1, 2, 3, 4. And then if you know the number before the x, that's going to be the slope. So we would say m equals 3. And that means 3 over 1 because the slope is rise over run. So we have 1, 2, 3, and then over 1. Down 3 over 1 just to emphasize our line. And then we can connect that like so. Whoops. Get that back over there. And put the little arrows because we know it goes on forever. Okay, so the next type of lines that I want to talk about are horizontal and vertical lines. Okay, horizontal lines will always be y equals and then some number. Vertical lines will be x equals some number. Okay, so when you are graphing y equals, that means that y, for example, y might always equal 4. What that means is all the ordered pairs will be with a y value of 4. So you can plot all those points, 1, 2, 3, and whatever number you want to put in for x. So when you plot 1, 1, 2, 3, 4, and 2, 4, and 3, 4, and 4, 4, you're going to end up with a horizontal line. And that's why it ends up being with y equals. And then the reverse for vertical lines, if we had x equals 3, for example, that means all of the x values are going to be 3. So you can put anything in there you want, 0, -1, 1, and then when you plot that, 3, 0, and then 3, -1, and 3, 1, you end up with connecting all those points and creating a vertical line. And finally, the last thing I want to talk about is be able to compare the graphs and look for similarities to make it easier for you. For example, if you were going to graph y equals 2x, it would be an intercept at 0 and then up to over 1. And it would continue that pattern for ever. Okay, so here's our line. And if we had y equals 2x plus 1, then this line, if we plot that, notice what happens. We can start at 0, I just want to get a different color. Start at 1, because that's your y-intercept, and then go up 2 over 1. So here's our next graph. It would be right here. And I am, I'm going to move it over just a tad. Okay? And so basically what ended up happening is the graph just shifted up 1 unit because of this number right here. So then what would you guess would happen if I gave you y equals 2x minus 6? Alright, you guessed it. It is -6, which means the original graph of y equals 2x, that's of, shifts down 6 units. So this one, if I had a 1, 2, 3, 4, 5, 6, it would take this and go 1, 2, 3, 4, 5, 6. It would be the exact same slope, all parallel lines, and that's about it for today. Thank you so much.